So you take aqueous lead nitrate. It's actually lead 2 nitrate. So lead would have a positive 2 charge. Nitrate has a negative 1 charge. You swap and drop. That's your formula. And since it's aqueous, that just means that it's a solid that you dissolved in water. That's what aqueous means. So you can't say that it's liquid. You can't say it's solid. It's aqueous. It's a solution. So that's how we know that this is how we write that it's a solution. So lead nitrate, aqueous lead nitrate reacts with aqueous sodium chloride. So we have to predict our product and then balance the equation. When you look at this, what kind of reaction would you say that would be? Double replacement. I didn't hear what you said, Brad. You didn't say anything? Double replacement. So this is a double replacement. The way we know this is because you have an ionic compound and an ionic compound. They're both aqueous. So ionic compound plus ionic compound yields 2 new ionic compounds. This is the cation, that's the anion, so positive charge, negative charge. Cation, anion, because it's positive and negative. So it's like Mickey, Minnie, Donald, Daisy. This is where Mickey and Donald trade spots. So your new product would be sodium nitrate. And then we know that sodium has a +1 charge, nitrate has a -1 charge. So we don't have to swap and drop. It's already written correctly. But what's the state of matter of this product?
One of them is going to be solid.
One of them should be a solid, right? This is how we know. You go and you get your solubility rules. And you look at your solubility rules. If you notice that most of these are negative, acetate's negative, nitrate, chlorate, then you have a couple exceptions here. This is sodium, potassium, ammonium. Those are positive, but most of these are negative. So when you're doing this, you're trying to predict your product, you want to look at the anion to see if it's soluble or not. So for nitrate, so that's what we're looking at here. Now we're looking at, sodium nitrate. Nitrate is soluble. So what does that mean, soluble? It dissolves in water. So if it dissolves in water, does that sound like liquid, solid, aqueous, or gas? So that's going to be aqueous. Now the next one, lead chloride. Since lead had a 2+ charge, chlorine has a 1 negative, PbCl2. Then what's the charge of what's the state of matter of lead chloride? So we come over here and we see chloride is soluble. So could we have 2 aqueous products?
It says except with PG.
So there's 2 things here. Number one, you can have 2 aqueous products. That means that what we would say that would be no reaction, is what we would say. But in this case, lead is the exception. Yeah, so lead chloride is not soluble, it's insoluble. So if it's insoluble, what state of matter would that be? Solid. That just means that it was a precipitation reaction. Is this balanced?
No.
Two in front of the sodium.
The 2 in front of the NaCl and the 2 in front of the Na.
Is it balanced?